Hello, welcome to our video about the Big Bang and fusion. All right. You've probably heard before about something called the Big Bang Theory, but I just want to give a formal definition here for it. So, the Big Bang Theory is a scientific theory for what happened when the universe began. Okay, so we're talking like beginning of time as we know it, basically. What do we think happened during that time? So, this theory doesn't address why we think these things happened, um, it just addresses what we think happened. Okay, so often you'll see some graphics like this. This kind of gives us an idea, maybe, of what the Big Bang was like. So basically, it's starting from a really small point, like smaller than we could even imagine, and all of a sudden, our universe expanding. So in the beginning, we think our universe was really tiny. The whole universe was in this tiny point, and that all of a sudden, it got bigger. Okay? That's basically what happened. And when this happened, so that's what we call the Big Bang. Um, we believe that protons and neutrons were first created during this time. Okay, so we got protons with a positive charge here and neutrons which are neutral and have no charge. All right, and also during this time, so these two things we think stuck together, boop, and they made hydrogen. So that is the simplest element in the universe, hydrogen. Okay, there's another one, a proton, and we got a neutron, boop, making hydrogen. Okay, and just a note, this is a special form of hydrogen, not the hydrogen that we usually talk about, which is actually just one proton with no neutrons. Okay. But you can write that on your notes page. So far we've said the scientific theory for what happened when the universe began was called the Big Bang Theory, and protons and neutrons stuck together and made hydrogen. Okay, so hydrogen was the very first element to exist. It's the simplest one. And these hydrogen atoms on the left here, eventually over time, they stuck together to make other elements like helium and lithium, which are the next two elements in the periodic table. So the thing is, atoms, including hydrogen, don't want to stick together. They don't want to combine naturally. And why is this? Okay, so on your notes page, this is the part where it says, why is it hard for hydrogen atoms to combine? I'm about to explain. So, right, remember that protons, so this is the nucleus of an atom. We're not showing electrons here, we're only showing the middle of the atom. And in the middle of the atom are neutrons and then protons. And protons have a positive electrical charge. Okay. So at some point in your life, you've probably held two magnets and tried to put them together. And depending on which way you're holding the magnets, sometimes they don't want to go together, right? It's like there's this invisible force that's like pushing them apart. And that happens when you try to put two of the same kind of ends together. So if you try to have like the north pole of a magnet and a north pole of another magnet and put them together, they won't go together. So atoms are like that too, where if you have a nucleus of two atoms and they have positive protons in there, they don't really want to go together. Okay, they repel each other. So they're like, no, we're not going to go. right? And that's because they have similar charges, just like magnets. Okay. So in the early universe, so how did these like atoms stick together to make new elements? They had to overcome this repulsive force that was pushing them apart. So how did they do this? The atoms couldn't have just been like, but we really want to get together. Something had to happen so that they could get together. And it has to do with heat. So when atoms get hot, they move faster. So in this cup of tea I have right here, right, this is hot. So the water molecules in here are actually moving faster than they would if I was drinking a glass of ice water. Those atoms would be moving slower. So hot makes atoms move fast. And the thing is, during the Big Bang, for the first few minutes after that, it was really hot. So we're talking 1 billion degrees Celsius, which Celsius is actually hotter than Fahrenheit, what you and I know for temperature. So the whole universe was this hot. And so you can imagine the atoms in our universe were moving really fast. Okay. So they were moving fast, and they were moving so fast that they were actually able to overpower that repelling force. The force that would normally push the atoms apart, they were going so fast that they just whoop, went right together. So this is showing that force getting smaller and smaller, okay, until those atoms could combine to make helium. So we just watched hydrogen atoms combine to make helium because they were going so fast because of that heat, because they were hot. Okay. And the same thing happened to make lithium. So hydrogen right here and helium also going very fast. They were able to combine and make lithium, which is on the right here. Okay, so this process of atoms combining to make bigger atoms is called nuclear fusion. Or you'll probably hear me just call it fusion. Okay. And that is because, if you think about it, nuclear is talking about the nucleus of an atom. So in this case, this nucleus and this nucleus are combining or fusing together, right? If you think about the word fusion, if we say something fused together, that means like it's stuck together, maybe glued together, they're coming together. So two nucleuses or nuclei fusing together, nuclear fusion. All right, so that's how these first three elements in the periodic table came to exist. We had hydrogen, but then we got helium and lithium. And this is just a fun fact for you. Almost all the hydrogen and helium in our entire universe, so including Earth, but all the space around Earth, almost all the hydrogen and helium was made in the first 20 minutes of our universe existing. That's kind of crazy. Okay. I think I'll skip this part. Don't super need to know this. And then we'll just spend a few minutes on this. So thinking about our sun, okay, the same kind of thing happens in our sun because our sun is really hot, right? So just like in the Big Bang, our sun can also get so hot that atoms inside combine to make other atoms. In this case, hydrogen turns into helium. Okay, our sun is mostly hydrogen right now. It does have a little bit of helium because it's making it. And I'll just give you some visuals here to show you. So these are hydrogen atoms, which are just a proton and an electron. Those were made in the Big Bang. Okay, and it has some helium. So in the core of our sun, it gets very hot. I mean, the whole sun is hot, but we're just talking about the core right now. It's so hot, the atoms, these hydrogen atoms, lose their electrons. So it's just protons. These protons are moving so fast they stick together, just like in the Big Bang. And then a bunch of series of steps happens. Okay. You don't really need to know all this, but just know a bunch of energy gets made when they combine. And yeah, we're gonna skip this. Okay. They just keep colliding until eventually they make helium. So basically the same thing that happened in the Big Bang is happening today inside of all the stars in our universe, unless they're dead. Okay. So we do get helium from stars, but most of it got made in the Big Bang. And that's all you need to know about the Big Bang and fusion.